Okay, this is 8.1, defining and using sequences in series. This is video 1. The essential question is, how do you find the rule for the nth term of a sequence? So we're going to first start by writing the terms of the sequence. But before we get to that, we need to talk about some special vocabulary here. So the term sequence, it is just an ordered list of numbers. We list these numbers and separate them by a comma. It's just a list. Each number in the list is considered a term. And the terms are the values in the range of the sequence. Alright, so let's talk a little bit more about sequences here. Okay, we're going to be talking about finite sequences, which means they have an end. Okay, they don't go on forever. And its domain is the set 1, 2, 3, 4, okay, up to the number it stops at. The domain are just numbers counting starting at 1. The range are the y values, okay? And they are the terms, they're the terms in the sequence. A lot of times I make a table and that's how I see the x and y's. That's why I said that. Sorry about that. And an infinite sequence is one that goes on forever. So finite, you see here that it stops. There's nothing after the 8. Where this one, it has a comma and then dot, dot, dot. I mean, dot, dot, dot means it's going to keep going forever. So you write a rule. And both of these sequences, if you look, it's counting up by 2s. 2, 4, 6, 8. Okay? So if I take 1 as my first term, and I say that would be like x or n. We use n a lot when we're dealing with sequences and series. Well, I would take it times 2 to get each term. So if n was 1, 1 times 2 is 2. Second term, so n is 2, 2 times 2 is 4. Okay, so that's where this rule would come from. Alright, so let's actually just write out the first 6 terms of our sequence. So for number 1. Okay, so we write our terms like I'd write A1, where n becomes 1 is my first term, and I'm just plugging 1 in for n. So it's 2 times 1 plus 5, and that equals 7. Okay, A2 would be 2 times 2 plus 5. So 4 plus 5 is 9. A3 equals 2 times 3 plus 5. So that'd be 11. A4 is 2 times 4 plus 5. And that would be, 8, so it'd be 13. A5, 2 times 5 plus 5 is 15. And A6 is 2 times 6 plus 5, and that's 17. Notice these are all counting by 2s. 7 plus 2 is 9, plus 2 is 11, plus 2 is 13. That's this 2 that's in front of the n. That plus 5 just helped us start with our first term at 7. So if I list these as a sequence, they're separated by commas. Here is my sequence. Okay, let's try that with number 2. Okay, so in this case, this one looks a little different, and that's okay. But we're going to plug in 1 for n. So sometimes what I like to do is draw a table. Especially when we're going to end up starting to write rules. So this one, you can do it just the same way you did the first problem, but this is just another way to do it. I'm going to have 6 terms. Okay, so think of these as the n values, okay? And then I plug it in. I plug 1 in for n, so I get a power of 0. Negative 3 to the power of 0 is 1. Okay? Then I'm going to plug 2 in. 2 minus 1 is 1, so I have a negative 3 to the first power is negative 3. Okay, 3 minus 1 is 2, so I have all of negative 3 being squared, so you're squaring the negative as well, so that gives you a positive 9. Okay, 4 minus 1 is 3, so negative 3 to the third is a negative 27. And then 5 minus 1 is 4, so negative 3 to the fourth is 81. And then 6 minus 1 is 5, so negative 3 to the fifth power is negative 243. So again, if you separate these all by commas, here would be your first 6 terms. So that's just another way to set it up. So now go to your practice and do problems 2, 5, 8, 9, and 14, and then move on to the second video.